My wife and I observed that FSD on my 2023 Model Y with hardware 3 seems less confident than the same version of FSD on my 2024 Model 3. The goal for this test is to determine if that observation is accurate. For this comparison, I'm using steering wheel shake as a measure of AI confidence. More shake infers less confidence. Of course, equating AI confidence with steering wheel shake is subjective, and the amount of shake is subjective in itself. Thus, the reason for this video. What do you think? Please reply in the comments. So in this video, the uh, the route's the same. Both cars are following the same route. It's actually from the grocery store to my house, and the videos were taken a week apart. That the only thing that was edited were, for instance, stopping at a stoplight where one car stopped and the other one didn't, and so on. The goal here is to actually show you side by side when the car is turning, because that's when most of the wheel shake happens. So what you'll find if you watch the videos closely is the cars are similar in a similar location on the route, maybe not always exact, but when they're turning, I try to keep it as close as possible so you can actually see a side by side of the cars turning. The open road is a chaotic and dangerous environment. If you recall the scene in Jurassic Park where Jeff Goldblum explains chaos theory, and he explains it by putting a drop of water on Laura Dern's arm, and he explains that the direction that the drip goes down is random, and it's dependent on a bunch of very minor details, very minor variables, and any one of those small variables can cause the water to go down a different path down her arm. And self-driving is a lot like that. There's millions of variables, and any one of those variables can have a slightly different effect. The reason I'm bringing this up is that I could probably do this run 100 times and get slightly different results. It's what makes evaluating self-driving so difficult. It's extremely hard to reproduce the same conditions over and over again. There are currently two versions of Tesla full self-driving computers in use. If you bought your Tesla before May of 2023, you probably have hardware 3. If you purchase your Tesla, after May of 2023, you may have hardware 4. Now, the terms may and possibly, probably, is because Tesla doesn't exactly have a model year. So it really depends on not only the month you bought your car, but actually where the car was built. So my 2023 car was purchased in March. Don't know when it was built, but it actually has hardware 3. So it was March of 2023 when purchased, the end of March actually in 2023 when purchased, and it has hardware 3. Now it was a Model Y built in Texas. The 2024 cars, they all have hardware 4. So the most important differences between hardware 3 and 4 is the number of neural net processors, the number of cores in the CPU, and the amount of RAM. So each of these full self-driving computers have multiple neural net processors, and each neural net processor has its own. It's called an SoC that has a number of cores. So it's a lot like in PCs when you get a PC and it's a 4-core PC or a 2-core PC. Same idea. But in this case, we're talking the difference. The hardware 3 has 12 cores and hardware 4 has 20 cores. These are massively powerful computers that are used for full self-driving. And that doesn't even get into the whole neural net processor thing, which is something that Tesla's doing that is just way outside of what anyone else is doing. So roughly speaking, very, very roughly speaking, if you have hardware 4 in your Tesla, that is about twice as powerful as hardware 3. And thus, that's why there's some differences. Even though they're running the same models in hardware 3 and 4, this is probably why we're seeing some of the shake. This is all speculation, so we don't really know for sure. could you open the door? Nick's gone. Sorry, he's at school. Josh is gone. He's at work.